All right, so here we go. Acids and bases. All right, they have two different what? Really? Faces, right? Thank you. Somebody was listening to the song from earlier. If you want to rewatch it, it'll be on my channel. Go, feel free to. Both of them. Anyway, guys, acids and bases, they're both electrolytes. What do electrolytes do? Conduct electricity. Why do they conduct electricity? Because there are... What's that, Cameron? They completely ionize, meaning what's in solution? What do they have in solution, guys? Ions. That's the key as to why they're electrolytes, why electricity can conduct, because there are ions. Acids have a sour taste. Bases are bitter. Acids turn litmus red. Why do you think I have red up there for all the acid stuff? And bases turn it blue, which is why they're blue up there. All right? Acids, folks, they will react with metals and form hydrogen gas. That is something that is very unique to acids, where bases will feel slippery to the touch. And then there are some examples that are listed there. If you don't have all those examples on your reading sheet from Friday, you may want to jot some of those down there in those sections. Things like vinegar, milk, soda, apples, citrus fruits, all are acidic. A lot of food, folks, is acidic. All right? Anybody ever hear of heartburn or ever have heartburn? Right? This is exactly what's happening, guys. Acid is starting to go back up your throat. All right? So you need to neutralize it by eating Tums or Rolaids. All right? Those are bases that are neutralizing the acid that's in your that is in your throat. All right? Bases, folks, some examples. Ammonia, lye, antacid, like I was just explaining, and baking soda. So a lot of cleaning products are bases. When we, either this week, probably not this week, but I'll show you guys at least a demo or so this week in class. But when we get back from spring break, we're going to do a few labs in this unit, a couple of them. One where you're looking at and identifying and analyzing household acids and bases, things that are that you might have around your house, and we'll see how they relate to acids and bases. All right, moving on, guys, our definitions. All right, the Arrhenius definition. Who can tell me what our definition of Arrhenius acids are? This is from your reading on Friday, so you should be looking on that worksheet. I will tell you guys when you need to look at your packets. Devin. Yeah, it increases the hydrogen ions in solution. Okay? Now, a piece I also want you guys to notice is that part of the Arrhenius definition also says because of those hydrogen ions that are in solution, it produces the hydronium ion. And the hydronium ion, guys, is this right here. So you need to jot that down in your notes somewhere. That is the hydronium ion if you don't already have it. All right? The hydronium ion, guys, is just H3O+. So because the Arrhenius definition, those Arrhenius acids release or increase hydrogen ion concentration when they are reacted in an aqueous solution, they produce H3O+, guys. So why this HCl is an acid by the Arrhenius definition is because it loses this guy right here, that hydrogen ion. It then goes and pairs up with the water molecule, forming H3O with a positive charge. Then you're left there with Cl-. So again, this is a definition, all right, H3O. So when you look at the reaction, when it plays out like I have right here, your acid plus water, you will see on the product side H3O+, that hydronium ion. All right? So it increases that hydrogen ion concentration, resulting in hydronium being formed. All right, that is our Arrhenius definition of an acid. Let's talk about a base. Okay? Bases. The Arrhenius definition is what? Who can tell me? Again, you should have had this written down. Andrew? Exactly. So it's kind of the flip side, guys. We're going to see with the Arrhenius definition. Acids produce H+, or the hydronium ion. Bases produce or increase hydroxide. So those are the two ions that we're going to be interested in this unit, and then also when we get back from spring break, is the hydrogen ion and the hydroxide ion. So it increases hydroxide ions in solution, and what it forms, or what you will see then, is that hydroxide piece in your reaction. All right, so right here, why NH3 is the base is because it's pulling off a hydrogen from the water molecule. So then now, oh, it's got NH4. Notice that it went up by, its H content went up by 1. That's going to play a part here in just a minute. And then you've got OH minus now in your reaction as a product. So that's how it increases the concentration. So again, these are two definitions. And I know I'm talking through them very quickly. You can go back and rewatch this video at a slower pace if you need to. All right. But you're looking at those two ions. H plus, acids improve, or not improve, but they increase the H plus concentration. Bases will increase the hydroxide ion concentration, the OH minus. Okay? Questions with those? Those are just the Arrhenius. This is the kind of the old definition. Some other people came along and they also kind of added to the acids and bases definitions. So we get what are called Bronsted-Lowry acids and bases. All right. Now, Bronsted-Lowry has a slightly different definition. Okay, still talking about those two ions, but we're really only interested in the H plus ion here with the Bronsted-Lowry definition. All right, so I'm going to say this statement. It's going to sound confusing, all right, but it's still true nonetheless. All Arrhenius acids are Bronsted-Lowry acids, but not all Bronsted-Lowry acids are Arrhenius acids. All right, because here's why. Arrhenius, guys, what ion is forming, or what are you increasing in a reaction with the Arrhenius that we just talked about? Hydrogen, right? H plus. So you're going to see some H plus that is present, okay, or the hydronium ion that's present, meaning it's reacting with water. Bronsted-Lowry, though, guys, it's talking about proton donors, okay? So acids are giving up that H plus, right? They may or may not produce hydronium. It depends on what they're reacting with, but they're still giving away that hydrogen ion. So it's slightly different than the Arrhenius definition. The Arrhenius part of it, like I said, was that you get the H3O plus, this hydronium ion, as part of it. Bronsted-Lowry, you can still have an acid without producing that hydronium. Now, this example that I have right here shows the hydronium ion right there, right, but it doesn't always have to. Okay? So acids are H plus donors. Bases are what, folks? Louder. What did you have from your reading on Friday? What did you say, Alex? They're proton acceptors. So acids, folks, are giving away the proton. Well, who's going to take them? The bases are going to take them. So they are proton acceptors. All right, they are proton acceptors. So if we look here at this example, guys, why HCl is an acid? Now, you got to look at it all in conjunction, okay, the whole reaction together. But acids typically start with what letter, guys? What element? Hydrogen, right? That's what that video we just watched was talking about. All right. So also now you might think, oh, HCl and H2O, they both start with H. Well, which one's going to be the better acid? Well, HCl, guys, is one of our common ones. It's a very strong acid, hydrochloric acid. And what it's doing here is it's donating this hydrogen, and then the water is acting as the base to take in or to accept that proton. When you give something or donate it away, do you ever get it back? No, right? And that's exactly what's happening, guys. This acid is giving away the hydrogen. So then it produces what we call a conjugate base. All right? This looks like the acid that we had, but what's different about it? What's different about that conjugate base? It's got a negative charge, and what else? What did it lose, folks? It lost the H. Oh, why? Because it's a proton donor. All right, so again, why this is an acid? It's losing the HCl. It's losing the H, which then is forming this chloride ion. So, folks, what we're going to start doing here is we're going to be looking at these things called conjugate pairs. All right, and conjugate is something you're only going to see conjugate in the product side. Jot that down in your notes. All right, you're only going to see conjugate. See the term conjugate in the product side of your reaction. Okay? So you start off with an acid and a base, and then your conjugates will be on the right. Because conjugate is kind of like what's forming. It's being formed because it's losing or gaining something. Okay? It's either losing a proton or it's gaining a proton. If it loses it, what is it? It's the... Nope. If it loses the proton, what does our definition say right there, guys? It's an acid. If it gains the proton, it is the base. So we look here. HCl was our acid because it lost the hydrogen, which then O. Can we all see that it forms the Cl minus? How can we see that? Because what? Their formulas look similar, right? So guys, what's happening when you're losing, your acid is going to lose the proton. All right, so what happens? Well, H is out of its formula now. And what happened to the charge? It got more, what? It can either be positive or negative, guys. Which happened here? It became what? Negative, right? Because we subtracted that positive away from the proton. Alex, you had a question. And then can we see, folks, that H2O looks like H3O, but what's the difference? Count up the H's that they have. This had how many on the left? 2. This had how many on the right? So what did it do? It gained a hydrogen, guys. That's what makes it the proton acceptor. That's what makes it the base. Very brief introduction. Now we're going to start doing some practice to talk about these conjugate pairs. All right? Let's take a look on page 2 in your notes. I'm going to jump ahead to where this is. You guys have these examples already. Conjugate acids and bases. Page 2 in your note packet. Okay? We're starting here with acids. How do we know these are acids? The ones that I have up here? They start with H. Okay, that's one good way. So they're acids. It says that they lose hydrogen. Now I know you have the answers right there, guys. But let's take a look. What is my conjugate base going to be if it loses it? So you're going to take H out of the equation. And it's just going to be what left? Cl. Now, with that H is not only the H, but also a what? Is it negative with the H? It's a positive, right? Because it's H plus. Now we're going to make a negative charge here with the chlorine, which is what I think you guys were meaning. Now here we go. What do you notice, guys, about H2SO4? How many H's does it have? 2. Is it going to lose all of them right away? No. It's going to take a couple reactions for that to happen. So for right now, when we write our reactions out, we're losing 1 hydrogen at a time or we're gaining 1 hydrogen at a time. So my formula of this is going to be HSO4. And what's my charge going to be? Minus. All right? You got the same thing here with bases. They gain it. So they're going to increase their hydrogen. Then what's going to happen to their charge? It's going to become more positive, right? Because you're adding that in now where we subtracted it before. So this is going to be H2SO4, and then this is going to be H3O positive. Let's go back and take a look at a couple examples that I had here. You're going to jot these down at the bottom of page 2, right here. These are bases that we have, guys. It's asking us to give the conjugate acid, the acid that is going to form when it takes in a hydrogen. So, Br minus. What is going to be the conjugate acid of Br minus? What are we going to add to the formula, guys? Hydrogen. So it's going to be HBr, and then what's going to happen to our charge? It's going to go away, right? Because it's a -1, and we're adding 1 to that. HSO4 minus. What is going to be our conjugate acid formula? H2, right? Because we had H1 right there. We're going to add a hydrogen to it because that's our definition of a base. And then SO4 along with it. Am I going to have a charge any longer? No, because I have a -1. So this is a -1 here. Plus 1 equals 0, which is what we have there. CO3 2 minus. That's carbonate. It's a base. What's my new formula going to be? HCO3, because 1 hydrogen at a time. Now, what's my charge going to be? Minus, right? -1, because this is 2 minus plus 1 equals -1. There we go. Not packing up just yet, folks. All right? Your homework tonight, what I want you guys to try to do is on page 3 in your packet. It's going to either give you an acid or a base. You're going to fill in the missing box. So number 2 right here, H3PO4 says it's an acid. What do acids do? What do they do with hydrogens, folks? They donate it. So they're going to what? They're going to lose a hydrogen. What's my formula going to be for the base, the conjugate base to H3PO4? Do your best with this, folks. We will go and review this tomorrow.